Normally you cannot directly instantiate an instance. For example, you could not call the constructor of the runnable interface, the interface used by the thread. It would be illegal to use. But Java does allow you to create an instance of an anonymous local class that implements the interface. There is a special syntax for creating an instance of an interface. This creates a local anonymous class, instantiates it, and assigns a new instance to the runner variable. You'll need to make sure that your class definition, the code between the other curly braces, implements all the methods of the interface. You can also create classes this way. The code below instantiates an anonymous subclass of object and assigns it to a variable. Anonymous classes are a useful tool in the Java developers' bag of tricks. Consider using them whenever you need to implement an interface or a subclass on a one-time basis. They are best used with smaller interfaces that have only one or two methods. Equal rights. Here is an issue that crops up in Java programs quite often. It's 3 AM after your fourth cup of coffee and you are trying to find the right logic to solve some complex programming problem. By now you're almost incapable of thinking about string and object references because the pillow is calling, and then the worst happens. No, it's not a Java spill, but this. You quickly compile and test the code, and it seems to work. Finally, time to go home and celebrate by snoring. Unfortunately, sometime later, application testing uncovers an intermittent bug and traces it to exactly this section of code. What, you say indignantly? I tried a string comparison like this the other day and it worked just fine. Possibly, but first let's revisit Java object reference concepts. An object variable is a reference pointer to the real object, which is stored in the heap memory. When you assign one variable to another, you are really assigning the reference, not the actual object. Java uses the equal equal operator to compare two references to see if they point to the same memory object. For string instances, the runtime does its best to make sure that any two string literals with the same character data point to the same internal object. This is called interning, but it will not help with every string comparison. One reason is that an interned value could possibly be removed by the garbage collector treat. Another reason is that the place where the string was generated may have created a new instance using one of the string constructors. If so, the equal equal comparison will always return false. The equals method is designed to compare the state of two objects, or what is inside each object. For your own classes, you must override this method for it to work properly, but string instances will always compare properly if you use the equals method. This next code segment illustrates the problem with assuming that all string values are entered. Note: rule of thumb: always use equals to compare two string values. Even though using the equal operator may seem to work, for most applications, even if it works, the equals code is simply wrong that only equals would write. So tell all your developer friends to support equals writes for the strings. Yes, that's probably the worst pun in this book. Resources: Vladimir Rubtsov. Does an object exist if you can't test its identity? Java World. Chapter summary. In this chapter, we've discussed some of the features that are available in Java 5 and some useful older API classes that are often overlooked by developers. In the next chapter, we'll focus exclusively on string processing. We'll look at some text-related classes in Java core, as well as some useful string processing classes from open source APIs. String utilities. Strings are a very important part of most Java programs. They are used for text display, data representation, lookup keys, and many other purposes. In this chapter, we describe some useful utilities and techniques for string processing. We'll be using regular expression patterns to compare strings, split delimited strings, find substrings, and perform substitutions. We will also consider utilities for string randomization, formatting, and conversion. Staying regular. Using regular expressions to search text. Unix administrators like to keep themselves regular, at least according to an old programming joke. Don't worry, this section is not about dietary fiber, but about a type of pattern matching known as regular expressions, or regex. For a long time, Unix power users have worked with commands or programs that are based on regular expressions. Such as grep, perl, set, and awk. Because this is such a powerful way of searching and manipulating strings, Java 1.4 added the java.util regex package to the core API. Of course, Java is platform independent, and these regular expressions will work on any system, not just Unix. The regex package has been in the JDK for a while, but I still find that many Java programmers have never used it. Regex patterns are a valuable starting point for many types of text processing, matching, searching, extracting, substituting, and parsing of structured content. In Java, you can easily determine whether a string matches a pattern using the appropriately named pattern class. Patterns can be as simple as matching a specific string value, or they can be much more complex with grouping and character classes, such as whitespace, number, letters, or control characters. Because they are just Java strings and are based on Unicode, regular expressions will also work with internationalized applications. The simplest pattern exactly matches a given string. In other words, the pattern is the same as the text that we want to compare. The static pattern.matches method is convenient way to compare whether a string matches a given pattern. The following will check to see if the value of the variable data matches the word Java. For directly matching a string against a pattern this simple, you probably wouldn't use a regular expression, since this is really just a less efficient version of Java .equals data. The real power of regex comes from using more complex patterns involving character classes and quantifiers. There are already many excellent books on regular expression patterns, so we'll look at only a few of the basic features of patterns and focus on Java's regex classes and methods instead. To give you a quick start, here are some of the special characters that you can use in regular expressions. Each of these represents a category of characters which in regex terminology is called a character class. Most characters match /d digits, / lowercase d digits, / uppercase d non-digits, / w lowercase word characters, / w uppercase non-word characters, / lowercase s whitespace, / uppercase s non-whitespace. Most characters match themselves in a pattern expression, but some have special meanings. The / escape character used above is one example. The following characters control how many times a subpattern is applied to the matching process. These are special characters that are treated differently than others. Question mark, star and plus. The following regular expressions matches the title of any ancestor, such as father, great-great-grandmother, or great-great-great-grandfather. As you can see from this example, it's possible to make more complex regular expressions by using parenthetical subexpressions. This next pattern expression will match anything beginning with a digit plus 0 or more non-whitespace characters. Be careful with the regex backslash character, since it is also the string literal escape character in Java. If you are using a string literal to hold the regular expression, you will need to escape the backslash character itself by using a double backslash. Yeah, that's right, you're escaping the escape. Pattern matching is also built into the string class itself. There is a new convenience method within the string class matches. You could rewrite the above code as the following. The pattern.matches method and the matches method of string are fine for one-time use. But for repeated use, they are less efficient. You can get a more efficient compiled version of the pattern for performing multiple matches by creating a pattern instance using the static pattern.compile method. The pattern object works together with the java.util.regex.matcher class. To do anything complex, you'll need to create a matcher. The matcher ties a pattern expression to a specific string. For performing more advanced matching operations, the following code snippet compiles a pattern for matching text made of word characters only. Remember that the matches method will match the entire input string against the pattern. If you want to check whether the string only begins with the pattern, use the looking at method instead. We'll discuss some other matching techniques in the next few sections, including finding substrings that match a pattern and performing text substitutions. Resources: Jeffrey E.F. Friedel, Mastering Regular Expressions, 2nd edition, Raleigh 2002. Slipsville, using the string.split method. Developers sometimes need to split a string into substrings using a delimiter such as comma, tab, or whitespace. As we discussed in the previous section, Java 1.4 added the pattern class for performing text comparisons with regular expressions. In addition to pattern matching, a pattern object can split a string into an array of substrings using the regular expression as the delimiter. For example, a one-line comma delimited list can be split into an array of strings using a comma as the pattern. Splitting strings is even more convenient than that. There is a split method in the string class. Let's rewrite the above code using this method. This time we'll also change the separator to include any white space before and after the comma so that it doesn't become part of the substring values. The same regular expression syntax applies here as in the pattern object described earlier. So the split method can be used for much more than commas and spaces. For help in processing complete comma separated value CSV files, see the book's website wickedcooljava.com. Smarty subbing, finding substring patterns within a string. The section staying regular, using regular expressions to search text at the beginning of this chapter describes how to use a regex pattern to combine whether a string matches or partially matches a given pattern. starting from the beginning of the input string. In this section, we'll be using regex patterns to find multiple matching values within a string. As an example, we'll search within a document to find any URLs embedded in the text. First, we'll need a pattern string that matches URLs. Here is one pattern that will match most URLs in common usage. This pattern is not completely sufficient to describe a URL, because it also matches some strings with invalid URL syntax, such as http ... a lot of slashes. It will also grab extra characters in some cases, such as comma or semicolon, that might follow a URL embedded in text. These are characters that sometimes will appear in a URL, but they are also things that you might not want to capture as part of the URL if it appears in text. However, the pattern is relatively short and will work well enough to demonstrate searching for URLs embedded in a text document. The parts of this pattern expression are as follows. Remember that matcher applies a pattern to a particular input string. To find multiple substring matches using the URL string pattern defined earlier, we must call the find method of a matcher. To find each occurrence of the pattern within the input string, we repeatedly call the find method to locate the next match. The find method returns false when there are no more matches. To retrieve the current match, we can use the start and end methods to get the index to matching data within the input text. The following code will print all the URLs found within the data. This will not match relative URLs such as images, pictures, /images/pictures.jpg that are often found in an HTML document or incomplete URLs that are missing the leading http ... such as wickedcooljow.com. To know when something is supposed to be treated as a relative URL, your program would need to have an understanding of the structure of HTML file. It's still possible to do this with regex, but more difficult. You would need to know the context of each match, and for that you must parse the document with an understanding of its grammar. See chapter 3 for more information. Resources for references on URLs and HTTPs and HTMLs, see books companion website at wickedcooljow.com. Getting captured using regex capturing groups. In the previous section we saw how to use a regular expression to search within a document to retrieve all the URLs inside it. We were able to retrieve the matching URL string using the find start and end method of the matcher class. Sometimes it's necessary to further process the result of a matching substring, perhaps looking for an additional subpattern. For example, you might decide to process URLs from particular domains. The brute force approach is to use another pattern and matcher object for this purpose by writing code something like this. It's not very efficient way to match domain names within the captured URLs. We have already done the hard work of extracting the URL with the find method. We shouldn't have to write another regex just to get a subsection of the result. And we don't have to either. Regular expressions give us the power to break the pattern into sub sequences of data by placing parentheses around portions of the pattern that we want to remember later. We can read these values separately from the rest. Let's write the URL pattern to make the domain name available separately from the other parts of the URL. When you have parenthetical groups in the pattern, you can retrieve the value that matches each group separately from the rest of the matching string. The group corresponding to each opening parenthesis is numbered, starting from 1 for the leftmost group in the above pattern. Group 1 is the protocol, for example HTTP, and the group 2 is the domain name to get the groups out of the matching string. Use the matchers group method. This simple code retrieves the domain name from each URL and prints out the value. Every matching group is saved so that the pattern can make a reference to it later. Referencing an earlier matching group within a pattern is called a back reference. To use a back reference to the third group, include /3 in the pattern. This will match only an exact repeat of the data that matches the earlier group. To illustrate this, let's consider a common mistake in the text documents: accidentally repeating a common word such as there or of within a sentence. Let's write a pattern to find these problems in a document. We can capture the first word following by some white space, followed by a repeat of whatever matched the first word. The pattern matches the following a white space character, one of a specific list of words, more white space, the same word repeating again, using the \1 back reference, and white space or punctuation. This match should be done in case sensitive mode so that we'll catch the beginning from the capital T and similar variants. The following code fragment finds occurrences of the pattern in a string using a case sensitive match.